Hello, good morning viewers. Still on how to graph a rational function, here is our third problem. We are going to graph this function, and the graph of this function is so special because it contains a hole on its curve. I will show you how it looks like. First of all, let us factorize this function. It can be factorized as we have our f of x, and this is equal to, we can factor out -2. So we have -2 multiplied by x, then -4. Divide by, this is a quadratic trinomial. We can factorize it as x minus 2, x minus 4. From here, you can see that this will cancel this automatically. What we have left is -2 divided by x minus 2. And this is what we are going to graph. All right, let us find our asymptotes. For the vertical asymptote, remember, if you want to obtain this, you're going to set the denominator equal to 0. So if x minus 2 is equal to 0, this implies that x is equal to 2. Therefore, we have our vertical asymptote at x equal to +2. What about horizontal asymptote? I told you we have two different ways of finding that. If you consider the function, it is bottom heavy. Therefore, we say our horizontal asymptote is at y equal to 0. And remember, you can still evaluate this function as the limit of x approaches infinity. That will also give us our horizontal asymptote. Next thing, let us find y-intercept. To find y-intercept, we are going to set x to be equal to 0. And we have y equal to -2 divided by 0 minus 2. This is -2 divided by -2, which is equal to 1. All right, when x is equal to 0, y is equal to 1. So y-intercept is at 0, 1. X-intercept, remember, you can obtain this by setting the value of y to be equal to 0. So we have 0 equal to -2 divided by x minus 2. And this is not possible because you can see our numerator is just a constant. So we say none. All right, remember I told you that this curve contains a hole. And how can we determine the hole? We can determine the hole by setting x minus 4 equal to 0. Remember, we have cancelled x minus 4. Once you set it to be equal to 0, you will obtain the coordinate of x at that point. So if x minus 4 equal to 0, this implies that x is equal to 4. So if x is equal to 4, what is the corresponding value of y at that point? We can substitute x equal to 4 in the remaining function, which is -2 divided by x minus 2. So -2 divided by 4 minus 2, and this is equal to -2 divided by 2, and this is equal to -1. So our hole is at x equal to 4, y equal to -1. So hole is at 4, -1. So now let's go ahead and construct this graph. All right, let us start plugging our points. Let's start with vertical asymptote. You can see it is at x equal to 2. So at x equal to 2, it means that the curve will never cross this point. Then for the horizontal asymptote, it is at y equal to 0, exactly on x-axis. Then for y-intercept, it is at 0, 1. So when x is 0, y is equal to 1. So we have our point exactly here. No x-intercept. Then for the hole, it is at x equal to 4, y equal to -1. All right, therefore I have to even remove 4 from that point. We have our hole exactly here. Now we can place some other points. When x is 3, let me see what is the value of y. When x is 3, we can substitute it directly here. Negative 2 divided by 3 minus 2 is 1. Therefore, y will be equal to negative 2. So when x is 3, y is negative 2. We have a point exactly here. Let me test for 2.5 in between 2 and 3. This is equal to negative 2 divided by 2.5 minus 2 is 0.5, and y will be equal to negative 4 at that point. So we have negative 4 exactly here. Okay, let me test when x is positive 6. We have negative 2 divided by 6 minus 2 is 4. And this will give us negative 0.5. It means that when x is 6, y is negative 0.5, half, exactly here. All right, let me connect these points together. And remember that this is our whole. The function is discontinued at that point. Okay, let us plug some other points to the left. Let's test when x is positive 1. When x is positive 1, we have negative 2 divided by 1 minus 2 is minus 1. And this is equal to positive 2. So when x is 1, y is 2. When x is 1, y is 2, somewhere here. Let me test 1.5 in between 1 and 2. Remember, we can never test 2. So this is equal to negative 2 divided by 1.5 minus 2 is negative 0.5. Negative 0.5. If you evaluate this, you have y equal to positive 4. All right. So when x is 1.5, we have our point somewhere here. Okay, let me test other points like negative 2 when x is negative 2. When x is negative 2, we have minus 2 divided by negative 2. Negative 2 is negative 4, and this is equal to 0.5. So 0.5 is somewhere here. I think let me stop here. We have just constructed our graph. Let us find the domain and the range. Domain, remember they are the possible values of x. All we have to exclude is the vertical asymptote and the x coordinate at the whole. So we have from negative infinity down to 2. Then the coordinate of x at the whole is 4. Then up to positive infinity. Okay, we have from negative infinity up to 2 union. Then from that 2 up to 4. Then from 4 down to positive infinity. So this is our domain. Then for the range, you know, they are the possible values of y. All we have to exclude are the horizontal asymptote and the y coordinate at the whole. So we have from negative infinity down to negative 1, which is the coordinate of y at the whole, then to 0, then to positive infinity. So we start with negative infinity down to negative 1, union from negative 1 up to 0, then from 0 down to positive infinity. And I think this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.